wrong. So this is our right. This is our YZ plane, and it's our out of plane. So for this case, our tau max in the YZ plane. Okay. And the last circle, as you can see now, right? So 5 as the biggest circle. And because it's touching point X and point Z, now this belongs to our XZ plane. And again, our out of plane has the biggest shearing stress. Okay, so if you look at this height over here, this is our tau max in our XZ plane, and it's equal to tau max. Okay. So for the third case, we have our and see that our tau max is equal to tau max in the XZ plane, and it is out of plane. And this will be equal to stress X minus by stress Z divided by 2. Okay. And that's our tau max. So this will be equal to our stress max minus by stress mean divided by 2. Because tau max is the radius of circle, right? So we can see from here again, we're going to label this stress A, stress B, and this is stress C. Okay, and what I've done is stress max or stress X is equal to stress max, and stress Z is equal to stress mean. Okay, so we have these three conditions, and more or less you know how to construct 3D Mohs circle already based on these three conditions. Okay, so what I'm going to do now is we're going to solve a problem. Okay, so this one problem I like to solve, and this problem that we're going to solve has a lot of layers. Okay, so example number 1. And we have to apply 3D Mohs circle. Okay, so let's look at this one. And this problem, I've posted the solution from the solution manual. Okay, and we are going to solve differently. Okay, we're going to find an easier way to solve this. Okay, and what's so unique about this problem is it combines 3D Mohs circle with stress strain curve. Sorry, 3D Mohs circle with U strap. Okay, let me elaborate. Okay, so this example why it's so unique is we're going to combine 3D Mohs circle together with U strength of the material. So that is what so unique. Okay. So this question states that for the state of stress shown, determine the two values of stress Y for which the maximum shearing stress allowable is 73 megapascal, right? So we know that the tau max is equal to 73 megapascal. So that is given to us, okay? And from this diagram, as you can see, based on the transformation, we know that stress X is equal to minus 50 times 10 or 50 megapascal. We know that the shear XY is equal to the shear YX, and this is equal to positive shear 48 megapascal. And also from here, we can see that stress Z is equal to 0. Okay, there's no stresses in the Z direction. So you ask me what stress Z, this is our stress Z. And also for this case, we the rest of the direction, we know that the shear XZ is equal to shear ZX, and this is equal to 0. And the shear YZ is equal to shear ZY and is equal to 0. Right. So as you can see from the 3D mole circle, right, there are two possible tau max, right, can occur in plane or out of plane. Right? There's two possibility. Like over here, right? We can see that condition number 1, right? We know that from here, condition number 1, right? Tau max happen to be out of plane, as you can see down here. Condition number 2, right? Tau max can be in plane. And condition number 3, you can see that tau max can be equal to that out of plane. Right? So there's two possibility. Tau max can be in plane or tau max can be out of plane. Okay. So what's so unique about this problem is we also know that stress yield is equal to twice of tau max. Right? So stress yield is equal to twice. So this is equal to 2 times of 73. And this is equal to 146 megapascal. Plus minus 146 megapascal. Now, some of you might ask, why is that? Okay, why is that? Okay, so if we were to sketch, okay, if we were to sketch mole circle, now if I'm going to sketch mole circle, I just briefly sketch mole circle. We know that so let me go to graph mode first. So I'm going to sketch mole circle. Right. This is our normal stress. This is our shearing stress, and we are very sure this is our point Z. Okay, that's our point Z. And we are given the condition that tau max is at 73 megapascal. So I'm just going to sketch our tau max is at 73. So this is our 73 megapascal. Okay, this is our 73 megapascal. And we are aware that we have a normal stress value. Okay, we are aware that we have a stress Z value. Okay, so again, as I mentioned, okay, I think I better sketch this properly. I don't want you to be confused. Okay, that's the last thing. I want you to be confused. All right. Right. And let me again sketch the two orange line properly. We have one line here. We have another line here. Right. And we know, right? So we know that this over here is equal to our shear xy, is equal to shear yx. And this is our shear xy equal to shear yx. Okay. And then if we were to draw one of the circle, right? And it has to touch point X, right? You have to touch point X. So this is one of the circle. All right. Right. So this is one of the circle. Okay. So if we look at this point over here, this point over here, what's the amplitude? Right. So we know from here to here, this is equal to 73. Right. So that's the radius. Over here, this is our minus 146. Okay. So if the circle goes beyond 146, yielding will occur. Okay. So this is where we have the plus or minus 146. Okay. So this is one possibility of how the circle will look like. Okay. And again, this over here is stress A. Okay, this is our stress A. Over here, this is our stress B. Okay. So that is why we say the yield is at 146. Okay. So what I'm going to do now is we're going to use the condition that the normal, that the shearing stress, the maximum is at sorry, the allowable is at 73, and the normal stress, the allowable is at 146. Okay, you just multiply by 2, because if this is 73, this is also 73, together is 146. Okay, so what I'm going to do next is I'm going to do a complete 3D mold circle. And what we want to verify, or what we want to determine, is what is our stress Y value that satisfy the condition where the maximum shear stress is 73 megapascal and the yield stress is 146 plus or minus. Okay. So we're going to solve this graphically rather than, if you look at the solution, they have all these funky equations. Okay. And you want to solve using this funky equation is up to you. Okay, it can can look pretty intimidating, but if you use the technique that I teach you, okay, it's really straightforward.